Good day, I'm Marvin Enriquez, your subject teacher for Probability and Statistics. With this video lesson, we're going to discuss the topic or topics null and alternative hypothesis, test statistic, and rejection region. Our lesson objectives. At the end of this lesson, you are expected to formulate the appropriate null and alternative hypothesis on a population proportion. Identifies the appropriate form of the test statistic when the central limit theorem is to be used. Identifies the appropriate rejection region for a given level of significance when the central limit theorem is to be used. For the introduction, the problem that challenges researchers is not so much the approximation of a population parameter, but rather the development of database decision procedure that can yield a decision about some scientific system. Sometimes it's very hard for the researchers to decide what test statistics they are going to use based on the scenario or the conditions being given on the experiment or in the problem. So the development of a database decision procedure is a more challenging than setting an approximation of a population parameter, because our decision should be based on the data or from the computation in our test statistics, whether we accept or not your alternative, your null hypothesis. If we reject your null, then we're going to accept your alternative. If we're going to reject your alternative, then we're going to accept your null hypothesis. So for instance, the BPAD must decide whether a new flu vaccine is effective or ineffective. So in dealing with this one, how can we identify if the new flu vaccine is effective or ineffective? By simply dealing with the data that we gathered from our survey, from our experiment. Then, from that data, by the concept of testing our hypothesis, because dealing with our experiment, we have our assumptions. So, for us to verify if these assumptions are acceptable or not, then we need to deal with testing the hypothesis. For us to know if this new flu vaccine are effective or ineffective. In this case, the BPAD infers something about the system. In addition, it must include the practice of experimental data and decision making that is based on the data. Because dealing with your new flu vaccine, it should be an experimental data. Because there are people who needs to be subjected here for us to verify if this new flu vaccine is effective or not. So our decision will be based on the data that we gathered from our experiment. Formally, the inferences can be put in the form of statistical hypothesis. That's why we need to deal with your testing your hypothesis, no? And then we apply your test statistic, the appropriate test statistic for this experiment for us to have a basis, no, in making our conclusion. Procedures that lead to the acceptance or rejection of statistical hypotheses, such as these include a major role of statistical inference. So we need to deal with the procedure that lead to the acceptance or rejection of statistical hypothesis, because dealing with this experimental research, no, at first we formulate your null and alternative hypothesis. So these are assumptions. Now, how can we verify or how can we assess if these assumptions are acceptable or not? So by simply dealing with your testing your hypothesis, applying the appropriate test statistic, then we can verify, no, if these assumptions are acceptable or not. Or we can bring these assumptions to the next researches, no, if these assumptions are acceptable. This will serve as a basis for a future researches. So let's review the steps of hypothesis testing procedure. First step is that we need to formulate the null and alternative hypothesis. So this procedure always starts with giving the two mutually comprehensive hypotheses. So the null hypothesis denoted by HO and alternative hypothesis denoted by HA. So before moving forward, no, in identifying to what test statistic is the most appropriate, no, for our researches, no, then we need to formulate first the null and alternative hypothesis. From that, then we can move forward, no, to the next step up to our conclusions. Because without dealing with your null and alternative at first, no, we cannot identify if that is a one-tailed or two-tailed, because the type of test statistic will be based on uh, hypothesis in the first step. That's why somehow it will serve as a foundation, no, in testing your in test statistic. So we need to formulate, no, first the null and alternative hypothesis before moving forward or before looking forward to uh, the appropriate test statistics that we can apply for our researches. Second step is that we need to identify the test statistic to use. So with the given level of significance and the distribution of the test statistics, we need to state the decision rule and specify the rejection region. So the rejection region, or the site that we need to subject in this test statistic, will be dependent on the sign that we put, no, in your alternative hypothesis. If that is less than, then we should subject the left tail of your normal curve. If that is greater than, then we need to subject the right tail of your normal curve. If that is not equal to, then we need to subject both your left and right tail, no, of your normal curve. So after establishing the null and alternative hypothesis, the next step is to choose the level of significance, so denoted by alpha. So this level of significance is the maximum error that a researchers want to meet in their research, no. So this the most commonly used uh, value of for this level of significance are 0.01, 0.05, and 0.10. So to understand the notion of level of significance, the researcher may commit two possible errors in testing hypothesis. So that will be your type 1 and type 2 error. So if the researcher rejects the null hypothesis, given that it is true, then he or she committed a type 1 error. On the other hand, if the researcher does not reject the null hypothesis, given that it is a false statement, then he or she committed a type 2 error. So there are two types of error that will be your type 1 and type 2, and there are probabilities that we can map for this type 1 and type 2 error. Alpha for your type 1 and beta for your type 2 error. So this table will shows to us, no, and for us to visualize more what is a type 1 and type 2 error. So let's deal with this table. So the table below summarizes the decision that the researcher could make and the possible consequences. So if your null hypothesis is true, so our correct decision is to accept it, right? So if we reject a true null hypothesis, that's a type 1 error. Because in reality, if your null hypothesis is true, then we need to accept it. Now, if your null hypothesis is a false statement and we accept it, that's a type 2 error. Because our correct decision for that, once your null hypothesis is a false statement, then we need to reject your null hypothesis. So that will be your correct decision for this type if your null hypothesis is a false statement. So for step number 3, so using a simple random sample of observation, compute for the value of the test statistics. So right after identifying what is the most appropriate test statistic, then we need to move forward for the computed value that we are comparing to, that we compare to your critical values. So a test statistic is a value determined from a sample information used to determine whether to reject the null hypothesis. Yes, it is considering the tossing of coin problem. In testing for the fairness of the coin, the appropriate test statistic is the number of heads occurred in n, or the sample size tosses. Let's say, for example, that your sample size is 100. So we can also use the ratio between the number of heads occurred and the total number of tosses. So for step number 4, it's all about making our decision whether to reject or fail to reject your null hypothesis. Again, no, as a researcher, we always want to uh, we don't we don't like to deal, or we don't like to prove that there is no significant difference between your two variables. As a researcher, we always want to prove that there is an existing uh, uh, significant difference between your two variables. That's why at first we always want to reject your null hypothesis, because it's a nonsense dealing with a research, and our goal is to prove that there is no existing relationship. So what is the purpose? So our main goal is to prove, or at first our main goal is to prove that there is an existing uh, significant difference between your two variables involved. Even if at some point there are times that we really need to accept your null, but again, as a researcher, we want to prove that there is an existing significant difference between your two variables involved. So decision rule is a statement of the specific conditions under which the null hypothesis is rejected, and the conditions under which it is not rejected. So the region or area of rejection define the location of all those values that are so large or so small that the probability of their occurrence under true null hypothesis is rather remote. So for step number 5, we need to state the conclusion. The fifth and the final step is computing the value of the test statistic. Check whether its value is inside the rejection region and making a decision to reject or not to reject the null hypothesis. So note, so we really need to focus of this topic is to discuss steps 1 and 2 of the hypothesis testing procedure. Why? Because your step number 1 will serve as your foundation. Your step number 2, we really need to find the most appropriate test statistics uh, that we can use for us to verify if our assumptions are acceptable or not. That's why it is important for us to give more time in formulating your hypothesis, in identifying what is the most appropriate test statistic, because from these two steps we can provide a reliable and valid conclusion. So what is it? No. Let's use this example for us to deal with this population proportion. So the principal of an elementary school believes that this year there would be more students from the school who would pass the national achievement test, so that the proportion of students who pass the NAT is greater than the proportion obtained in previous year, which is 0.75. So there is a population proportion here, which is 0.75. So what will be the appropriate null and alternative hypothesis to find this belief? So please do take note that the second to the fifth steps of hypothesis testing procedure will be discussed in the next lesson or visual lesson. So there is a keyword here greater than uh, the proportion obtained in previous year, which is 0.75. So from our previous discussion, we always said that uh, this words greater than is a more specific than, for example, at least. When we say at least, when you say that the value should be greater than or equal to that value. But when we say greater than, it is more specific than the word at least. So we simply use this greater than, and an it will never represent equality between your two variables. That's why we are going to use this greater than to your alternative hypothesis. And we always said from our previous video lesson that the null hypothesis will present equality between your two variables involved. That's why our null hypothesis for this example is that the proportion of students of the school who passed the NAT or national achievement test this year is equal to 0.75. So if we convert these uh, statement into symbols, that will be equal to P is equal to 0.75, because we assume, or our assumption, that the proportion of student will be equal to 0.75, and your null hypothesis will always show you an equality between your two variables involved. Now, let's move forward in dealing with your alternative hypothesis. So there is a keyword is greater than here. It is more specific than the words at least, at most, no. Therefore, we simply use this greater than to represent your alternative hypothesis. So our statement for this alternative hypothesis is that the proportion of the students at the school who passed the NAT this year is greater than 0.75. That's why if we convert this one, that your alternative hypothesis now is your proportion of student P greater than 0.75. So it shows or it will never show you an equality between your two variables involved. So that will be your alternative hypothesis, totally opposite of your null hypothesis. Note, a statistical hypothesis is a statement about a parameter and deals with evaluating the value of the parameter. So, in making your hypothesis, no, dealing with your null and alternative hypothesis, your null will show you an equality. Your alternative is totally opposite of your null. And using this hypothesis, these are assumptions that we are comparing your parameter and your specific value. Now, we always assume that your specific value will fall within your parameter, or it will fall, no, in your parameter. So the null and alternative hypothesis should be complementary and non-overlapping. So whatever the value that you put, no, in your null hypothesis, the same value that you should put, no, in your alternative hypothesis. For example, if you assume that your p is equal to 0.75 in your null, then we use 0.75 in your null, then we should use 0.75, no, same thing with your alternative hypothesis. It should be complementary and non-overlapping. The difference is that the symbols that we use, no, the words that we use, as long that your statement represent an equality, that will be your null hypothesis. As long that your statement does not represent an equality, then that will be your alternative. And it's automatic that your alternative hypothesis is totally opposite of your null hypothesis. So generally, the null hypothesis is a statement of equality or includes the equality condition, as in the case of at least. So there is an at least, greater than or equal, or at most less than or equal. But most of the time, no, we don't need to put your greater than or less than. But most of the time, no, we simply use equal. So if there is no keywords on the problem being mentioned, no, we simply use equal sign, because your null hypothesis will always represent equality between your two variables. But again, if there is at least, at most, then we simply use greater than or equal, less than or equal sign in your null hypothesis. At some point, or it will represent an equality. It can be greater than or less than. At the same time, it can be equal to. So our test concerning your proportions. So in the previous section, population mean is the primary concern. It was made sure that the given population mean is no longer true based on a certain test like C-test or T-test. In this section, so checking of the population proportion is the main concern. If it still holds true or no longer true. So for instance, no, we may check the percentage of females in the province is still significantly greater than 50%. Since sample proportions are normally distributed, no, a given random sample from a population can be standardized. Hence, if p hat is a random sample proportion, then it can be transformed into a C-score using the formula. So we use this computed C here, your p hat minus your PO, all over your square root of PO, 1 minus PO, close parentheses, over N, or your sample size. So PO plus your QO must be equal to 1. So you need to take note of that. Your PO plus QO must be equal to 1. Your P hat is the sample proportion. that will be equal to x over n. Your x is the number of successes and n is the number of size. And your PO now is the given population proportion. So in general, for a one-tailed test, your HO or your null hypothesis, your P is equal to PO. Then your HA, your P is greater than PO, and the rejection region is your C greater than your positive C sub O. Or if your HA is less than, your P is less than PO, and the rejection region is C is less than your negative C sub O. And for the two-tailed test, because we simply use not equal to in your symbol in your alternative hypothesis, meaning say we don't know if your P is greater than or equal to, then we simply assume that your P is not equal to PO because your alternative hypothesis will always show you, uh, or will never show you an equality between your two variables involved. Same thing with your null hypothesis now. Your P is equal to PO. Same thing with your your null hypothesis in your one-tailed test. So the rejection region is your C less than your negative C sub alpha over 2, or your C is greater than your positive C sub alpha over 2. So sometimes the sample proportion P hat is given directly, such as 60% of the respondents, which may be written as P hat is equal to 0.60. So when we have to calculate P hat, as in 70 out of 100 respondents were interviewed. So we use the computing formula. Your P hat is x over n, so the number of successes over your sample size. So thus, your P hat now is equal to 70 over 100. So that will be equal to 0.70. So the critical values of C are found in the table of the areas under the normal curve. So by using the same procedures as presented in the previous topic. So again, your P hat is equal to x over n. Then you simply substitute this 70 to your x, then 100 to your n as your sample size. Then we just simply divide 70 by 100. That will be your P hat. No? So for your activity, suppose that the average passing percentage of the College of Nursing in the last 10 years in the board exams is 97%. In this school year, there were 300 students who took the exam and passing percentage is 98%. Since 294 passed, what would be the null and alternative hypothesis? So that will be your activity for this video lesson. So thanks for watching. If you want to like, comment, share, and subscribe, so please do so. I'm Marvin Enriquez, your subject teacher for probability and statistics.